Welcome back to the lab. The computer you are using right now is a miracle of engineering. It can do billions of calculations per second. But there are some problems it simply cannot solve. Simulating a complex molecule for a new medicine or cracking the ultimate encryption code would take a normal supercomputer millions of years. It would take longer than the age of the universe. But there is a new type of machine coming. A machine that doesn't follow the rules of our world. It follows the spooky rules of the quantum world. Today, we will explain quantum computers without the confusing math. To understand the quantum leap, we first have to look at your current computer. It works on bits. A bit is like a tiny switch. It is either on or off, 1 or 0. Everything you see, photos, videos, games, is just a massive pile of ones and zeros. It is very rigid. A switch cannot be kind of on. Now meet the qubit or quantum bit. A qubit is not a switch. It is more like a spinning coin. While it is spinning, is it heads or tails? It is both. It is in a state of superposition. It is heads and tails at the same time until you stop it and look at it. Why does this matter? Let's say you have 2 bits. You can have 1, 10 or 11, but you can only be one of those combinations at a time. With 2 qubits in superposition, you can be all 4 combinations at once. If you add more qubits, the power grows exponentially. 300 qubits could hold more states than there are atoms in the entire visible universe. This allows the quantum computer to calculate all possible answers to a problem simultaneously, rather than checking them one by one. Imagine a giant maze. A classical computer is like a mouse running through the maze. It tries a path, hits a dead end, comes back, and tries another. It is fast, but it has to check every path one by one. A quantum computer doesn't run. It floods the maze with water. The water goes down every path at the same time. It finds the exit instantly. This is why they are terrifying for cybersecurity. A quantum computer could find the prime factors of your bank password in seconds, something that would take a normal computer thousands of years. There is another weird rule called entanglement. We can link 2 qubits together so they become twins. Even if we separate them by 1,000,000 miles, if you change one, the other changes instantly. Einstein hated this. He called it spooky action at a distance, but it is real. This allows qubits to talk to each other faster than light, creating a unified superbrain. So why don't we have them on our desks? Because qubits are incredibly shy. Any noise, heat, or vibration makes them collapse. They lose their magic and become normal, boring bits. To keep them stable, we have to freeze the computer to near absolute zero. That is colder than deep space. Building a quantum computer is like trying to balance a pencil on its tip during an earthquake. So, we are just at the beginning. We are like people in the 1940s looking at the first massive vacuum tube computers. The revolution is coming, but it will take time. We talked about the flow of information. Now, let's talk about the flow of matter. Why does smoke rise smoothly and then suddenly turn chaotic? In the next video, we will dive into fluid dynamics, laminar versus turbulent. Don't forget to subscribe. See you in the lab.